Hello, my name is Danielle, and over the past 6 months, I worked with two teammates, John and Austin, on a project for the Klamath Inventory and Monitoring Network, a branch of the National Park Service based here at SOU. What we built for them is an automated data validation pipeline, a system that catches data errors in ecological field records before they reach analysis. We'll walk you through what that means and how it works. Our client is KLMN, one of 32 monitoring networks across the country. Their mission is to provide reliable, long-term ecological data to park managers, and they do that by tracking 9 ecological vital signs across 6 national parks in southern Oregon and northern California. Those parks are Crater Lake, Oregon Caves, Redwood, Lava Beds, Whiskeytown, and Lassen Volcanic. They're tasked with getting the full picture of whether an ecosystem is healthy from its vegetation, streams, and caves. Field crews go out to monitoring plots with tablets every year and collect that data. All of that data flows back into Microsoft Access database, maintained by their data manager, and that's where our project starts. To give you a sense of scale, watch how far it scrolls before it finds what it's looking for. They're working with over 70,000 nested plot records and nearly 30,000 overstory records, accumulated over 12 plus years across 6 parks. What you're watching is what validation looked like before our pipeline. You would open Access and manually locate each record by hand to figure out if an error. Sorting duplicate tags was hours of manual cross-referencing, and the historical checks, DBH changes, species code changes, canopy cover drift, and new species detection, none of that was automated at all. Historical data validation was simply too difficult to do without automation, every season, for every data submission. What we built is a pipeline that runs 11 validation checks in a single command or one button click. It reads directly from the Access database with no format conversion needed, always works on a time-stamped copy so the original is never touched, and autocorrects safe issues like wrong case park codes, while flagging everything else for human review. Every run produces audit-ready, reproducible output, a corrected database copy, an Excel edit log with autocorrections on one sheet and flagged records on another, and a CSV summary. On the right, you can see all 11 validation checks we made. Austin will now spotlight validations 5 and 7 to give you an understanding of what a validation looks like.
The first validation I'll focus on is DBH, which stands for Diameter at Breast Height. This is the standard measurement for how wide a tree trunk is. Because trees grow slowly, any jump of 50% or more between monitoring visits is almost certainly a data error and not real growth. This usually means a wrong tag was scanned, a typo was entered, or 2 separate tree records got mixed up. This validation matches each tree across the current and historical databases by tag ID and clump letter, finding the most recent baseline and flagging anything over that threshold. And with 3 or more historical visits, it can use linear regression to project the expected value and flag based on the standard deviations, which is much more precise than a flat percentage. Before this validation was created, each individual tree's history would have to be looked up and compared by hand. The other validation I wanted to highlight is the duplicate tag detection, which our client stated was the most time-consuming part of manual validation. So let me give you some background information as to why this can be an issue. The field crews assign a physical tag number to individual trees at each monitoring plot. The same number can appear at 2 different plots, and this is expected and not an issue. But the same tag appearing twice at the same plot means something went wrong. Maybe the record was entered twice, a wrong tag was scanned, or 2 trees got conflicting records. Before this validation, catching this meant exporting the entire data table and scanning thousands of rows for repeats. This was a process that could take hours to do by hand, but now this runs in seconds. We designed the validation so that every record that has a duplicate is flagged so that our clients can pull up every affected row without any additional searching required. Now, let's get into how this actually runs. There are 2 ways to run this pipeline. The first option is with the R console, which requires a function call that supplies the database path, a historical database path, and the validations you want to run. And this is useful for developers or automated workflows, but the main interface we designed for the KLMN staff is a Shiny Browser app, and I'll now pass this off to John, who will explain how to use this.
What you're looking at is the Shiny Browser app. Now let me show you what it's like to use it. This is the interface that any non-technical user would see. No R console, no command line, just a browser window that opens when you click Run App in RStudio. This is the moment where it stops being a pipeline, starts being a tool. I'm going to walk you through a full run from a blank screen to a downloaded set of output files in roughly the same time it takes the pipeline to run. The first step is to provide the path to your database. You can type it in directly, or hit Browse. A file picker opens, and you navigate to your MDB file, just like you would in Windows Explorer. You can see two database files in the data folder, the master historical database and the current seasons file. Highlight the current one, hit select, and the app validates it immediately. When a valid MDB is selected, file found is shown in green right below the path field. If the path is broken or the file type is wrong, it flips to red. Once your databases are set, every one of the 11 validation checks is enabled by default. You can uncheck any of them, say, if you don't have a historical database handy and want to skip the cross-visit checks. Once the ready indicator is given, we can start the validations. There's a quick check option for lightweight pass, useful mid-season when you just want to catch the obvious stuff fast, without waiting for the full statistical analysis. The blue button is for Run Validation, which runs all enabled checks and writes full output files. Orange is Quick Check, faster, lighter, no file output. Blue is for the whole shebang. For tonight's demo, we're doing a full run. Here you can see the full settings panel with both databases loaded, current season and historical. When a historical database is present, the app automatically enables the cross-visit checks, DBH change, canopy cover change, and species code change. You can also see the configurable thresholds. The SD threshold for DBH flagging defaults to 3 standard deviations. Canopy cover threshold is 20 percentage points. Both are tunable by the user per season without touching any code. The live log on the right streams progress in real time, table by table. You can watch it work. When it finishes, the status banner updates, and this is what a completed run looks like. The pipeline processed the full TerVeg database, 7,976 records, across multiple tables and came back with 1,178 flagged records, 19 distinct flag keys, and 0 autocorrections on this particular dataset. And a row of download buttons appears at the bottom. No refreshing, no hunting for the output. You click, they download, and appear in your output folder. The Excel edit log is what the user will actually work from. It has 2 sheets, autocorrections and flagged records. You're looking at the flagged records tab here. Every row is a single flagged issue. The column tells you the table it came from, the data ID so you can trace it back to the exact record in Access, the flag code, and a plain English description of the problem. Take this row, tag 21, DBH of 40.2 centimeters, but the expected value based on its historical growth pattern was 38.4 centimeters. That's flagged as 75 standard deviations above expected. The pipeline didn't just catch that something was off. It tells the user which tree, what the value was, and how far outside normal it is. There's also a fixed checklist output, a separate Excel file, they can use as a structured to-do list for working through the flags one by one. Beyond the Excel files, the pipeline also produces a corrected copy of the Access database, time-stamped, so it's never confused with the original. The original is untouched. This copy has flag columns added directly to the affected tables in Access. So, if anyone opens the database to look at a tree record, the flag code is sitting right there in the row. No cross-referencing a separate spreadsheet. And in the lower left, that table is the flag key. A human-readable legend mapping every flag code to what it means and what action to take. That's part of the output also. So whoever picks this up 6 months from now doesn't need us to explain anything. And there you have it. I'll hand it back to Austin to talk about the impact numbers.
At the start of this project, anything that required past visits was done manually. You would have to open up the historical database, find the record, compare values, write down the issue, and repeat this for every single tree, plot, and season. What this pipeline changes is that the detection of these issues are now done automatically on every run, and validations like the duplicate tag detection and others just take seconds. All flags are generated, categorized, and written to output files without anyone changing the original database. And based on the data we worked with, 85% of the 7,976 records were issue-free and do not require manual review, meaning the remaining 15% that the pipeline did flag is now what our clients can focus on, which is a much more focused use of their time. Lastly, this pipeline was designed so that anyone on the KLMN team can use it, understand it, and ultimately save them time. Thank you for your time. We will be happy to answer any questions you have, or you can scan this QR code to visit our website with more information about our project.